On January 27th, 1967, Grissom, White, and Chaffee were to conduct a practice countdown at Pad 34 at the Kennedy Space Center. And that test was no different from tests which had been done on every mission up to that time. The astronauts got into the command module. Eventually, the hatch was closed and the spacecraft was pressurized with pure oxygen, and they went through their practice countdown. But at 6:30, around 6:30 p.m., there was a call from inside the spacecraft, "We've got a fire in the cockpit." And at that point, things progressed with alarming speed. It was just 20 seconds later that there was a cry of pain and the radio went dead. The technicians struggled to open the hatch, which was a three-piece hatch, the innermost portion of which actually opened into the cabin. And it took quite a few minutes because of the heat and the smoke for them to open the hatch. And at that point, they discovered that the astronauts were dead. This was a complete shock to everyone at NASA. No one had even considered the test to be dangerous. And yet, here they were, they had lost three astronauts, and the people who could have saved them were just on the other side of that hatch, and they could do nothing to help them until it was too late. Immediately, NASA launched an investigation into the tragedy. And what they found was very disturbing, that the signs had been there and they had been missed. The pure oxygen atmosphere that was used in the test, when you pressurize pure oxygen at 16 pounds per square inch, which is what was used in the ground portion of the test, slightly above atmospheric pressure, that is like a bomb waiting to go off. And yes, there had been concern about fire in the spacecraft and what would they do and how would they put it out. They thought they had removed any potential source of ignition. But it turned out that there were a lot of materials in the cabin of the command module that aided the spread of the fire. First, the spark that started the fire, they never really determined exactly, but it probably came from wiring that had been exposed in the cabin. There had been a number of wire bundles inside the command module that had been exposed, and you had workmen going in and out of the capsule during testing and maintenance and assembly, and some of these wire bundles might have gotten damaged. And once the fire started, it spread rapidly because there were quite a few flammable materials. There were nylon netting under the couches, under the astronauts' couches, that was designed to catch pieces of gear if they should drop them during the test. There were pieces of Velcro on the cabin walls, which would be used in space to let the astronauts stick a piece of equipment that they weren't using so that it wouldn't float away, like a camera or a flight plan. Velcro is very flammable, especially under pure oxygen. And even things that didn't normally burn, again, in that 16 psi pure oxygen atmosphere, became food for the fire, fuel for the fire. In fact, aluminum pipes containing flammable coolant actually burned through, and the coolant then aided the spread of the fire. The worst of it was that three-piece inward opening hatch could never be opened once the fire started, because the fire caused a buildup in pressure. And so Ed White, who was in the center couch, was, at the time of the fire, reaching over his head to try and undo the bolts, which took, under normal conditions, 90 seconds to open. But after 20 seconds, the astronauts' air hoses burned through, and they were suffocated by toxic gases. They did not burn to death. They were suffocated by the toxic fumes of the fire. Well, NASA came up with several important changes to the Block 1 command module to make it spaceworthy and to prevent this from happening again. Number one was a quick opening, outward opening one-piece hatch, which could be opened in seconds, you see in the center picture, by pumping a handle. There was a new spacesuit covered with fireproof beta cloth, which is actually a fiberglass fabric, which is then coated with Teflon. The number of flammable items in the cabin was greatly reduced, in fact, reduced almost to an absolute minimum. And the other change that was very important, when the spacecraft was on the ground, including during pre-launch testing and at launch, there would be a mixture of nitrogen and oxygen to reduce the flammability. And then as the spacecraft ascended towards space, the nitrogen would be vented and you would be left with an operating atmosphere of about 5 psi of pure oxygen, which would be roughly the concentration of oxygen that is down here on Earth, since we have 20% oxygen and 75% nitrogen, 73%. And the entire spacecraft was overhauled, and wiring was made safer. There were fireproof materials put on wiring on the backs of instrument panels and so forth to prevent any sparks and so forth. The entire spacecraft was essentially redesigned from a fireproof flammability standpoint. And, as much of a tragedy as it was, and, you can look back and say, well, they saw that there were so many problems with the Block 1 command module, but they knew they had to fly, and so they pushed ahead with the program. Yes, all of that was true. They figured they'd fix the problems on the Block 2 version, which was meant for the lunar flights. But the fire actually proved to be a blessing in disguise, though it exacted a terrible price. Because if it had happened in space, they would never have gotten the spacecraft back. They would never have known what went wrong. It probably would have meant the end of the program. As it was, all the changes that they made prevented future crews from experiencing a terrible tragedy, from which the program would never have recovered. And many people that I talked to, including Deke Slayton, the head of the astronaut corps, said that the fire probably saved the race with the end of the decade for the lunar landing. Well, the Soviet Union learned a few months later, in April of 1967, that they were not immune from tragedy when they tried to fly their new vehicle called Soyuz, which means Union. And Soyuz was a prototype, an Earth orbit prototype, of the spacecraft that they hoped would eventually take cosmonauts to the moon, around the moon, in lunar orbit, and so forth. There was a separate vehicle, as we'll see later, for landing on the moon. But this Earth orbit version of the Soyuz was launched in April of 1967 with a single cosmonaut, Vladimir Komarov. And the flight had problems from the very beginning. One of the solar panels did not open properly. Komarov didn't have enough power in the spacecraft because of the solar panel that wouldn't open. It was decided that he would come home, and he had also problems with his orientation sensors on the spacecraft, so had to line the spacecraft up manually for a manual reentry, much more difficult, but he managed to do that. But then the final malfunction was in the parachutes, which did not deploy properly, and turned out after the fact to be the result of a mistake during the preparation of the parachute assembly. Anyway, Soyuz 1 hit the ground at very high speed and was destroyed, killing Komarov, and this set the Soviet moon program back by 18 months, about the same amount of time that Apollo had to stand down for its own recovery effort. And so as we get into 1967, we see that both sides in the moon race have learned that the race to the moon can exact a terrible price. I'm Andy Chaikin. We'll see you next week.